Yeah, you will be able to customize the personality, adjust the voice, and over time the robot will actually learn about you, remembering your preferences and routines. You will not even need to always give clear commands because it will begin to understand you without words. Exactly. Tesla has built the Optimus robot, which is capable of walking, lifting and carrying objects, performing chores at home, and even helping with tasks like preparing food or assisting with child care. At the same time, Neuralink has shown that a brain implant can translate human thought directly into actions. So what happens when these two breakthrough technologies finally meet in the same system? We are suddenly looking at a future where people may control an entire group of robots simply by thought alone. This is no longer distant science fiction. It has already begun to happen. But before we go deeper, welcome to AMP Drive. If you enjoy future technology and want to stay updated on Tesla's biggest innovations, make sure to subscribe right now and turn on the notifications. Our community is growing fast, and your support means the world. So join us on AMP Drive today to never miss the next big reveal. Now, why exactly must the Tesla Optimus robot be paired with Neuralink? A brain implant is not just a Bluetooth headset or a wireless controller. Even in the most successful clinical cases so far, the electrode threads used by Neuralink can shift slightly after surgery, which causes weaker signals. That is on only a very small number of human patients. We still need long-term data about brain tissue reaction, possible scarring, inflammation, and the durability of those extremely thin threads over many years. Up until recently there have been only 3 Neuralink implant operations reported. Yet Elon Musk has once again taken the boldest step anyone could imagine. Tesla revealed an Optimus prototype that is integrated with a Neuralink brain implant. We have already heard so much about what Tesla Optimus might eventually do. Everything from cleaning up rooms, taking care of older adults, supporting children, and even being a reliable household companion. But the truth is, Optimus is not widespread yet. Its dexterity is not quite at a human level, its cost is still very high, and many people still do not fully trust it. When a technology has a launch price ranging between $50,000 and $200,000, it is difficult for the public to adopt it quickly. These factors are part of why household robots have not fully captured people's imagination. But that was before Elon Musk introduced the radically updated Tesla Optimus Gen 3.5, equipped with none other than a Neuralink implant. The idea of merging a humanoid robot with a brain-computer interface will naturally spark debate, but once people see how it changes Optimus, their opinion will likely shift in a major way. If you always thought humanoid robots are just clumsy machines that walk slowly, you would be mistaken. If you believed they could never approach human intelligence, you would be wrong again. Artificial intelligence is developing at breakneck speed, moving these machines far beyond what most people expect. Elon Musk is pouring billions of dollars into this program to push the Tesla bot to practical use cases, with the plan of beginning sales as early as next year. Skepticism is natural, but the hidden advantages are worth examining carefully. According to Tesla's latest information, Neuralink plans to raise the number of electrodes per implant from around 1,000 today to more than 25,000 in the near future. Later, this number could grow into the hundreds of thousands or even millions of channels if multiple implants are used. Each electrode can be seen as a tiny window into the human brain. The more of these windows that exist, the clearer the full picture of brain activity becomes. Once the electrode network is as dense as the brain's own cortex, Optimus will be able to receive sensory and motor information in a way very similar to how our brains work. That means artificial intelligence can join decision-making with coherence and sophistication. This instantly makes AI interaction smoother and far more precise, from responding to changes in the environment in real time to handling intricate tasks that normally require human skill. To make the point clear, let us compare Optimus without a Neuralink chip to Optimus with one. At this moment, Tesla's robot is already impressive. It can walk gracefully, bend its arms naturally, lift boxes, fold laundry, and carry out repeated tasks with surprising fluidity. Tesla has trained it with advanced AI tools that allow it to react to real-world data from cameras and sensors instantly. But if you watch any demonstration closely, you will notice something. The movement still feels slightly mechanical. When it touches delicate objects or reacts to sudden changes, there is still a gap between its skill and natural human instinct. It is good, but not fully human-like yet. Now consider Neuralink's work. The company is building ultra-small brain interface chips that can actually decode electrical signals directly from the human brain. In the first human trials, a paralyzed patient was able to move a computer cursor just by thinking about moving his hand. That is not science fiction, it really happened. Now many people are asking, what if this brain-inspired technology is applied to Tesla's robot? Optimus could gain not just programmed intelligence, but human-like reflexes, instincts, and rapid learning patterns. Picture this scenario. You return home after a long workday. Optimus greets you at the entrance, ready to help. You tell it, please organize the living room, and it instantly begins picking up toys, folding blankets, and putting pillows neatly back in place. It is efficient and polite. Yet you may still feel a moment of doubt when you watch it lift a fragile glass. What if it slips? Or when you hand it a silk shirt to fold, you wonder, will it wrinkle the fabric? Optimus today still needs many repeated attempts to perfect fine movements like shirt folding or cup handling. It learns like an assistant who is skilled but not entirely familiar with your habits. But if you upgrade Optimus with Neuralink-inspired feedback, the story changes dramatically. When it picks up your glass, it instantly feels the slipperiness and adjusts its grip in real time, just like your own hand would. Instead of stiff programming, it has a reflexive adjustment. Tesla already showed Optimus serving popcorn at the Tesla diner, handing a box to a customer with a wave and a thumbs up. While its movements are still slightly cautious and slower than a person's, it completed the job smoothly without dropping anything. The updated footage demonstrated how Optimus coordinated environmental awareness with human-like social interaction, adding gestures like waving, thumbs up, and even heart shapes with its hands. What stood out most was how Optimus noticed when it was holding a cup too firmly and corrected its grip naturally. That single act shows a leap in robot dexterity. Now imagine this applied to cooking, laundry, pet care, or even elder care. A silk shirt is folded correctly after just one attempt instead of thousands. A tired look toward the kitchen might be enough for Optimus to ask if you want dinner started. Sitting on the sofa with sore shoulders could prompt it to dim the lights and bring a blanket. The interaction feels more natural and context-aware, with Optimus sensing moods and intentions rather than waiting for strict commands. By blending sensory input with brain-like reflexes, the robot moves beyond mechanical behavior into more human-like responses. Elon Musk has explained that the core of Neuralink is the N1 chip, a miniature system that functions like eyes, ears, and hands for the brain. It records neural signals at up to 20,000 samples per second on each channel, like capturing every note of an orchestra. The N1 chip also sends signals back into the brain, creating two-way communication. In humans this lets paralyzed patients control computers. In Optimus, it closes the loop between sensors, decision-making, and movement. Tesla's robot already runs on advanced neural networks modeled after self-driving systems. Neuralink decodes patterns across thousands of channels. Together, they shift Optimus from just reacting to performing smooth, instinctive actions. Neuralink patients practice moving a cursor by thought. Optimus does the same with tasks, but learns much faster through this feedback. Tesla estimates it could cut fragile object handling errors by more than half, making Optimus nearly as responsive as a human. Here is where things become transformative. Neuralink in people links to a single brain, but Optimus robots can instantly share what they learn across thousands of units. If one robot gains a new skill, all others receive it immediately. With Dojo reaching 1.1 exaflops of power, the Optimus network could act like a global brain where each robot is a cell contributing to an evolving intelligence. Neuralink takes a vertically integrated approach, improving hardware, software, and even the surgical robot together. Tesla applies the same idea to Optimus with custom chips, actuators, and constant updates. Each completed task improves both the robot and the overall system, creating continuous progress. With these upgrades, robots may go far beyond factories and chores. They will perceive, decide, and act almost on their own. This brings concerns: will jobs be lost? Will healthcare lose its human touch? Musk has suggested Optimus could serve as a full-time nurse, always on duty, able to lift patients and analyze health data instantly. Critics remind us that empathy is irreplaceable, so building trust will be essential. Even so, Optimus could spark new industries. Trainers, programmers, technicians, and human-robot interface designers will be needed. Robots would take on heavy or repetitive labor, freeing humans for creativity and strategic roles. The economics are striking. Musk sees Optimus selling for under $20,000, with each unit able to earn about $2,000 monthly. That means a robot could pay for itself in under a year and then keep generating income. Businesses could use multiple robots to cook, serve, take orders, and clean. The upfront cost may seem high, but the return would come quickly, turning Optimus into both helper and revenue source. As with past revolutions, robots will not just replace jobs but create new ones and redefine human work. Just as self-driving cars created roles in remote supervision and AI development, humanoid robots will push society toward advanced skills. This is not only about efficiency but also about expanding human potential. So what do you think of Tesla Optimus paired with Neuralink? Could this fusion of reflexes and shared intelligence transform daily life, or does it raise too many risks? Share your thoughts in the comments. Thanks for watching Amp Drive. Be sure to subscribe so you never miss the next Tesla update coming in just 2 days. If you enjoyed this video, like and share it to support our channel. We look forward to bringing you more exciting stories on Amp Drive.